So for our warm-up here, again, what we have is our triangle within the circle. And it's asking for answers in terms of, so they ask us to find the area of the circle, easy peasy. And then number 2 says the triangle, so it's actually drawing our height to find the area for our triangle. And then it says sector, we talked about how the sector is our wedge. And then the shaded segment, which is actually written there. And they call that the segment of the circle. Okay. So first of all, let's go and do our area formula for a circle. What is our area formula for a circle? Pi r squared. Pi r squared. So our area for circle O would be 49 pi units squared. All right. Now for number 2, it says triangle AOB. What is the formula for area of a triangle?
1/2 base times over 2.
Good. 1/2 base times height. Now, what type of triangle do we have here?
An equilateral.
It ends up being an equilateral. We have the isosceles because those are both radiuses. They are the same length. And when we go to find our remaining angles there, they end up being 16, 6 as well. So it ends up being an equilateral triangle. Now, because it's an equilateral triangle, so this is 16, and this is 7, and this is 7. So that means that this whole thing here is going to be 7 as well. Now, because it's an equilateral triangle, we could technically use a different formula to find our area. What else could I use instead of 1/2 base times height?
Yes.
You could find the area of the 6390.
Yes, and we will do that. But that's going to still be using our height there.
Oh, 1/2 AP.
Yes, we could do our 1/2 AP because that's the formula for any regular polygon, and equilateral is a regular triangle. Now, I think for this particular one, the 1/2 base times height is going to be easier, but don't forget that 1/2 AP works when it's an equilateral.
Didn't you end up having to use your apothem anyway?
What's that?
Didn't you end up having to find your apothem anyway?
Well, we find our height, which isn't the same as the apothem. But you could use your height to find the apothem. It's just, let's just do that. Okay, so I'm going to go ahead and draw in my height. And when I draw in my height, this is my height here. I'm going to draw it in my big picture here. We have that it splits that angle in half. So this is a 30-degree angle, and this is 60. So we have a 30, 60, 90 triangle. Now, if this is a 30, 60, 90, they gave us our hypotenuse. How much is just this going to be?
Half of the hypotenuse.
Half. Good. So 7/2 or 3.5. And again, the entire thing is 7. Okay, and then we have to find our height here. So now that we have our short leg, we know our height. What is our height going to be?
3.5 the square, not the square, 3 root of root.
What? That's square root of 3. Yes, good. So 7/2 or 3.5 square root of 3. Good. Okay, so let's use that. Oh, what's my base going to be? 7. Yeah, so remember base and height are perpendicular. So my base is 7.
What's the h, the height?
7/2 root 3, or 3.5 root 3.
7 divided by 4.
Alright, so I have 1/2. My base is 7. My height, we said, was 7/2 root 3. Alright, so I have 7/2 times 7/2. So 49 over 4 root 3. And you could write it as 49 root 3 over 4. That would be units squared. Not a nice number. Can't reduce the 49 over 4, so that's just our answer. Questions with their triangle? Alright, so now let's take a look at our wedge. Now, our wedge is just a portion of my circle. So I need to figure out how much of my circle do I have. Alright, so what's my fraction? Well, it's 60 degrees. I'm going to write that as 6. I have 60 degrees out of 360. What fraction is that? 1/6. Good. So I have 1/6 of my circle. We want the area of that, so I just have 1/6 of my area. So my area of this sector, the cube wedge, is 1/6 of the area of the circle, which is pi r squared. We already found up here. 49 pi squared. Alright, can I reduce 49 over 6?
No.
Nope. So this is a lovely number, 49 pi over 6. Alright, so now our shaded segment. How do I find that? How do I find number 4? What am I subtracting? Good, the triangle and the wedge. I want to take that triangle away from the wedge, and that little curved crescent thing is left over. Alright, so I have my area of the wedge minus my area of the triangle. And so that would be my wedge was 49 pi over 6 minus 49 root 3 over 4. Oh, that's nice. They wouldn't combine that into one fraction.
No.
What? Come on. Let's get them both to be a multiple of 2.
But I thought you said we can't do it unless it's a...
Well, it's going to be still a frac or a subtraction on top, but we could at least have one bottom. Times 3. What's 49 times 2? It's only one away from 50. Good, 98. So 98 pi over 12. Ooh, what's 49 times 3? It's one away from 50, so 50 times 2. Good, 47.
With the calculator.
So I could combine this into one fraction and say 98 pi minus 147 root 3 over 12. Honestly, though, I would probably do it like this.
Yay!
But I just want to see what it would turn out.
No.
Okay, questions with that? You will see this again on your test in various forms.
Wait, what? No.
Okay, questions with this? Alright, let's go take a look at our homework. Was there anyone's homework I did not check? Okay. We'll talk about that after we go over homework. Okay, let's go and take a look at our homework. Let's do spheres first. Yes, I'm sorry.
Two?
Which one's the one where it's 49 pi?
Oh,
yeah, that one. Can you put the pi next to the fraction?
Yeah, so you could write it like this. 49 over 6 pi. Just make sure your pi doesn't sneak underneath. This would be perfectly fine. You do this. That's kind of sneaky underneath. Yes, sir.
After the test, are we gonna have another unit or are we gonna have this alone?
So our next unit will be transformations/constructions. It's a little mini unit, and we do that with S4 review.
Okay.
So we will have we'll have a quest on the transformations and constructions. We'll have a little mini quiz on S4 review. So it's in one unit, but there's a separate thing for the transformations and constructions.
I didn't get number 2.
All right, what about number 2? Are you stuck? Are you okay with getting the height? Okay. Are you okay with the fact that this is a 30-60 90 triangle? Okay. So my short side is 7/2 because they gave me my hypotenuse. My short is half the hypotenuse. So if my hypotenuse is 7, then my short side is 7/2. Then my long side is my short times root 3. So that's where my 7/2 is going. That was my base, or that was my height. And my base, which is the side here, which because it says equilateral, then that's 5 times 7, or it gets cut in half, so you can say 7/2 times 2, which is 3. And then just Alright, let's go take a look at spheres. And spheres actually end up being one of the nicer shapes because triangles don't come into it. With all of our other shapes, with our prisms and with our pyramids, triangles often come in, which requires us to do a lot more work. Or we have those regular polygons that could come in, which require more work. But for spheres, they don't come here. Okay, for number 4, I'm sorry, I didn't leave it in terms of pi. Let me write up what the pi was. Okay. So number 4, oftentimes guys, you'll be asked to leave it in terms of pi. So our volume would have been, I'm thinking correctly, 3.659 pi, or if you left it in fraction form, 1372 over 375 pi. 374. And then our area was 7.84 pi. So if we left that in fraction form, 196 over 25 pi. So usually they ask you to leave it in terms of pi. Not always though.
Ah.
Okay, let me go and sneak this down a little bit so you can see it. Alright, do we have questions on 2 or 4?
So I put 165 for.
Yeah, for number 2, that's fine. Yeah, you can write it as 165, just make sure that pi doesn't sneak to the bottom. And guys, make sure you have units for these. Feet cubed, feet squared, meters cubed, meters squared. Other questions on these 2?
Hey, why should we put pi over the 6? At 1/6 pi.
That's the same thing. That's Patrick was just asking the same thing. Yes, please.
I don't know how to multiply
So it's 4/3 pi r cubed, so 1/2 cubed. Okay. And guys, our formulas, remember volume is measured in units cubed, radius cubed. Our area is measured in units squared, radius squared. That might be kind of helpful there. I showed you 2 where technically the surface area is the derivative of the volume, which just simply means I were to take my exponent, multiply it in front, reduce my exponent by 1, then I would have 4/3 times 3, which does cancel. It would be 4 pi r squared. You don't have to remember that. That just helps some people in remembering the 2, or you can just memorize them directly.
I didn't get number 4, but I didn't get
Number what?
volume. I had the exact same setup, and then when I multiplied, so it's 1.4 cubed, I got 2.74.
Did you then remember to multiply by 4/3? Maybe you forgot that part. Are there other questions on 2 or 4? Alright, so then number 6. Numbers were out of the way.
49 pi.
So here with our surface area, we can't forget, it's not just half the surface area for the sphere, we have to add on that bottom circle as well. Something looks fishy with my volume there.
Did you divide it by 2? 1 or 1/3?
1600 over 3 is not 5,333. 1600 is not bigger when you divide by 3. Is that supposed to be 16,000?
No, that's what I thought.
16,000, I lost a 0 here.
100 or 12?
There should be 3 zeros because it's cubed.
The
I'm working. Let's say something divided by something should not get bigger. Okay, do we have questions for number 6?
oh, this is a fraction.
What's that?
Right? Don't they get
Fractions?
bigger?
Fractions are good.
If you divide it.
Oh, if you divide by fraction, yeah. Yes, you're correct. If I divide by 1/3, it would get bigger. Divide by 3 should not yield a larger result. Alright, so let's go take a look at the back side. Now, I know you didn't have to do number 9, but number 9 is pretty similar to 8 in that I'll ask for you to find something else given the volume or given the surface area. So it's very similar to 8. Just set up your formula, plug in what you have, and solve for what's left. Those are good types of questions. Alright, do we have questions on 8? And do you guys know what a silo is?
It's where you store grain?
Yes, it is where you store grain. There's one like over there behind the
It's
school.
one soap.
Were you driving
Softball fields. I don't think it's actually has grain in it, it's a non-functioning.
Isn't that scary little farm thing?
Is the farm scary?
Did you know
It's
that?
like very.
It's only scary if it has nuclear weapons in it.
Right.
It's Margaret.
So the silo back there is this shape. I don't know the,
It reminds me of the farm in a quiet place. Just kind of like.
it is a farm. It used to be a quiet place. Connor, what was your question, dude? You good?
It used to be a quiet place.
Herndon didn't used to be this populated back in the 60s or 50s.
Used to be like,
Back in my day. Come on now, not that.
Back in the 1800s.
All right, so your silo here, it asks just for the volume. They could have asked for surface area, in which you would have had to do lateral of our cylinder plus a base, and then just half of this figure. So just keep in mind those composite figures sometimes it changes. If you left number 10 as an improper fraction,
Minus 1.
you would have had, hold on, I did it earlier. I think it was 8 something. Oops. Your improper fraction would have been 8705 over 3. Oh, no, 8704.
Yeah.
Sorry. 3 times 1 is 3.
What?
So if you would have left this as an improper fraction, you would have got that.
oh wait, so I did like, so second to last step where I got like that. How did you get that one? Okay.
So this is with the pi actually multiplied out. You had 29.01.3 for keeping
Yeah,
the pi. And then 11, you didn't have to do. And then 12. I lost my 4 there. 12 is just our big sphere, take away the small sphere. And since they're both in terms of pi, we could actually combine together. 2016 pi.
Yeah.
I should change that so it's 2019. Is that what yours is? Is it 2019?
Yeah, but it will be updated.
I know, every year I should change it.
2020.
Not having these
If they copy the homework, they're gonna get it wrong.
There you go, that's why I changed.
I have a question.
Okay, hold on, I'll come back to what's
How did you add up 2,560 plus the 1,000?
24.
Yeah.
So you'd want to get this with a common denominator. I think what I did here though is I found what this was as a mixed number and then just added those together. So like you could either put this in common denominator 3 and add them together that way, or write this as, that'd be what? 3, 4, 1 and 1/3, I think, and then add it together. Other questions with this? Let's go and bring up similar solids. Now, just a refresher with similar solids, what we learned is that we have units, our scale factor, so anything measured in units, so height, length, width, circumference, perimeter, anything that's measured just in units, that can give us our scale factor. Let's just say it's A to B. Now, if we want to talk about area, which is measured in units squared, then our ratio would be A squared to B squared. And if we want to talk about volume, which is measured in units cubed, that would be A cubed to B cubed. We use those ratios to help us set up a proportion and solve for unknown values. So sometimes you take it back to your original scale factor and then build it back up to the square root of the cubed. So that's what it comes back to every time. Let me go. Zoom in a little bit more on this. So then take a look at 2, 4, and 6 here. Let me go over questions with this. Do we have questions on these ones, guys? Number 6. So a cylinder and a cone, each with 6 meter radii and 4 meter heights. So because it's a cylinder and a cone, those are 2 different shapes. They can't be similar solids. They have to be the same shape. That's like saying, are they similar? Nope, because they're not even the same shape. Do we have any other questions on these ones? So let's go break up 8, 10, 9. Yes.
So I don't really like understand how like it makes it similar. Like, I mean, the fractions don't simplify, so why does that make them similar? Like for number 2, they're just random numbers, you know?
Those are all.
Like so you're comparing it. So you're going to compare like length with length, width with width, height with height. If you get the same ratio, then that means they're similar because they have the same ratio,
Okay.
right? So similar solids means that it's the same shape and the sides are proportional when we had 2D shapes. Now that we're in 3D shapes, we say corresponding dimensions are proportional, which means match up the same things, and if it's the same ratio, then it's a similar solid.
And then, can 2 like different shapes be similar? Like
No, they have to be the same shape, like the same solid. So like, back when we were doing 2D, a square and a circle were not similar. And so same with 3D, like I cannot say a cone and a prism are similar, because they're 2 different things. Let me bring this back.
How did you do this to be able to find the sides? Or
Which one are you talking about?
just like this
For number
section? Yeah.
So here they told us, it says each one is similar, so we know it's similar. And then it says use it to find the scale factor. So the scale factor goes back to just your units. So here, number 8, I start off with volumes. So now I go from volume to get back to units. I have to cube root it because it's volume is units cubed. My scale factor is just units, so I cube root it.
Oh, I think I love.
And then like for surface area, that's area, so that's units squared. I need to go back to just units, so square root it. Yes.
I know we only had to do units, but for 9, I couldn't figure that out.
Oh, so guys, with all of these, always simplify first if you can, because it's going to make your numbers easier to work with. You don't necessarily have to. You can go ahead and cube root or square root, and then you have to break down your radical and then simplify from there. And sometimes you just have to. But if you can simplify first, then it's going to be easier to work with. So like for number 9 here, I'm going to go and write mine as a fraction before I turn it into a colon. So 150 over 294. I know that I can reduce both of those by 2. So it's the same thing as 75 over, let's see, 94, so 147. Let's see. Is that right? I don't think I can reduce it any more from there.
Yes, you can by 3.
By 3? Sweet. Awesome.
45 and 49.
Oh, that's gonna be even nicer.
Yeah. Oh, okay.
And then
And then
find the square root.
So I could have square rooted at this point. Let's say you did. Let's say you're like me. You're like, I don't think I can break it down more. I would have square rooted at this point, and then you would have to break it down. So 75 breaks down into 25 and 3. So that would actually be 5 root 3. And then you'd have to break this down. And that breaks down into 3 and 49. So this actually becomes 7 root 3.
And then you take
And
away
then
those
those reduce. And then,
Okay, yeah, because I was, for the other ones, I was weird.
yeah.
I tried from it.
Yeah.
I didn't get.
So you can go ahead and square root from the beginning. It's just the numbers are a little harder to break down. So if you can simplify the beginning, do that first before you square root it. Sometimes you can't. You just have to deal with the square root like we did here. But if you can simplify it first, it just makes your life easier. It's fine.
Why here the
Root 3 over root 3 reduces down to 1, so I just have 5 over 7. Just like 5 over 5 reduces down to 1. Root 3 over root 3 reduces down to 4. Yeah. So then, like, for number 12, guys, so they told us that the figures are similar, and they gave us surface area. So before square rooting this, 108 to 192, you can go ahead and square root and break those down like we did up above, but I would reduce it first. So then you have smaller, easier numbers to work with. So half of 108 is 54. Actually, can 4 go into it? Let's try 4. Let's see. 4 goes into 10 2 times with, okay, never mind. We'll just do it in halves. We'll get it there. That. All right, so 54. What's half of 192?
Well, no 40, no 50, no.
So it's 8 away from 200. I mean, 46.
We have
96. 96.
I'm just kidding.
I just had to add the 50.
And then I would keep reducing. Again, we could square root at this point. Let's reduce more if we can. What's half of 54?
27.
Add and divide.
What's half of 96? Could I reduce that even more?
You were right.
Again, you can stop this first, but we can reduce it by 3. What's 48 divided by 3? Okay, so my surface area is actually simplified down to 9 over 16, and then the square root's going to be a lot easier. So this is my units. Okay, I'm going to write it here. Surface area is 9 to 16. So now I'm going to go back to, that was units squared. So I'm going to go back to just my units, square root it, so I get 3 to 4. Now let's take a look at what we need. We need volume. So volume is units cubed. So 3 cubed is 27. 4 cubed, what is 4 cubed?
4 times 4 is 64.
Okay. So now I can use this ratio
I feel.
to set up and solve for my volume. So my ratio, my volume is 27 to 64. And it says that they gave us the volume of the larger figure. So I need my volume larger is given, find volume smaller. So I don't want my smaller.
It's really
And then you have my
I
smaller.
did like 9 pieces or something. I don't know why.
we do that for number 14.
So Lena, you probably forgot to square root it first before you built up. So guys, with these, we always have to go back to our units before we can build up to something else. Yes, Jocelyn? Sure. Connor, did you have a question?
Was that for 12?
Yes.
This takes out paper back.
Well, that's how you do it. So again, when they give you something, set up your ratio, simplify it as much as you can. And then, depending on what they gave you, take it back to units, either square root it or cube root to get back to units. And and then when they ask you, build up to get it. So here they ask for volume, so I can cube that to my volume, and then set up your proportion.
Oh.
So again, here we have to cross multiply. Okay, so we take a look at the back side.
Okay.
I'll report last. I'll report whatever you
What's
guys
that?
do, whatever you guys want.
So 14, it told us that a shipping box holds 350. A larger shipping box has dimensions triple the size of the other box.
Okay.
So how many golf balls does the larger box hold?
I'm multiplying.
So it says a larger shipping box has dimensions triple the size of the other box. So would you guys agree that from our, let's go small to large, and it says dimensions, so dimensions are just our units. It's triple the size, so 1 to 3. Does that make sense?
Yeah.
And then it's talking about it holds 350 golf balls. What is that talking about? Volume. So I want my volume, which is units cubed. So it'd be 1 to 27. And I use this to set my proportion.
That makes a lot more sense.
So my volume ratio,
3 cubed is.
and they told us it holds 350, and we want to know how much does the larger box hold.
Because
So again, you have to get half of the units, and then what are they asking for? Asking for volume, so units cubed.
that makes sense.
And then cross multiply.
Equals 9, what was the number?
9450, I think.
Thank you.
Sorry, I can't get it anymore.
I got my 0 right.
Alright, so 16 is very similar to 12. And 20 was very straightforward. There's nothing crazy with that. Just make sure you simplify first. Like for number 20, if you said that their scale factor was 69, that's not fully correct because it's not been simplified. And if you said their surface areas was 36 to 81, again, it's not simplified. So make sure you simplify before you square and cube.
Okay, don't worry.
What does the setup look like for 18?
Oh, yeah, true.
So they gave us dimensions for the thermos, radius, and height. And then it says it holds 10 fluid ounces. How many ounces will a similar thermos with a radius of 3 inches? So they gave me the radius of 3 here. I want to compare that with my radius here. Okay. Now radius is measured in units. So my radius would be 2 to 3. Now it's talking about 10 fluid ounces. What is that? That's volume. That's volume. And volume is units cubed. So my volume, units cubed, would be 8 to 27. So here's my ratio for my volumes. There, 8 to 27. And they told us the 2 radius, that's 10, and the 3 radius we want to find. And then you cross multiply.
So it's all just the same setup.
It really is just take what you have, get it to your units if it's not your units, and then build that up to what you need. Set up a proportion, cross multiply.
Why does it give us the height? Then?
Just to mess with you, to make sure you know to match up your radiuses and not the height of the radius. Like we don't go 2 to 5
Yeah, I was like,
because I don't have the height over here. We have radius from radius, height to height. So it's extra information that you don't need. I guess you could technically also just find
The volume?
volume,
Because
although
it's
it's not about fluid ounces though. I don't know. Might be a little wonky. Alright, do we have other questions on 16, 18, or 20? 20 is 2 to 3, 4 to 9, 8 to 20. Here, I'll move it up for you.
we learn about it.
Yeah.
He's from Ghana. Ghana.
So simplify first. 16 6 to 9 reduces down to 2 to 3, and then square it. So simplified.
Why are you guys talking about Shanghai?
We have a test there. And
Because Shanghai is
is the grad.
As wonderful as whatever class that is, this is geometry.
Hi, John.
Okay, do we have questions on, oh sorry, I didn't bring up 24. So 22 is error analysis. Why is the classmate wrong? You can't just say because he is. And
Because
then
he sucks.
24, again, so these are our volumes. You can cube root this right here if you really want, but I would recommend simplify first before you cube root it. Heights are measured in just units, so simplify cube root, that gets you your 3 to 10. And then use that to get your area as units squared, so you get that.
Oh, I got it right. I didn't simplify, like, I didn't do that.
Yeah, so always simplify first to make the numbers smaller and easier to work with. Because you don't want to have to do the cube root of 135 by hand if you don't have to.
What is 23?
23 is 64 meters cubed.
Yeah.
So it tells us the lateral area, and it tells us the volume of the larger. So lateral area is talking about area. So 64 to 144. Again, you could reduce that if you wanted to, but that's lateral area, so it's units squared. If I go back to units, square root would be 8 to 12, right? Now, let's simplify it. Again, we could have simplified here, but let's simplify this. What would 8 to 12 simplify down to?
The
2 to 3.
2 to 3. So now it says the volume, so we want to get our volume, so units cubed. So 2 cubed is 8, 3 cubed is 27. This is the ratio I use for my volumes. So 8 to 27 equals the volume of the larger cylinder is 216. And they want us to find this. You guys will notice that, especially for these types of problems, we don't get too crazy large numbers. So you'll want to know what 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7 cubed maybe, but like we're not going to have you do 12 cubed. That's going to be really large numbers. We don't want. You can do that, you just have to then simplify your answer. Yeah, you would still get you just have bigger numbers you're working with. So you would get a larger thing here, and then there'd be larger numbers here, just in the end, you would simplify down to the same answer. Other questions? Yes?
So can you remember, like, 6 here, you do 6 and 6 times 6, and it was 36 times 6?
Yeah, and you can always just off to the side if you need to. Okay, let's go take a look at our assignment sheet. Because I am making a change to this. Hold your breath.
I'm taking a test now.
No, the test takes the whole class, not half of it. Okay, so I am going to move the test one day later. So if you would adjust this on your assignment sheet,
2 review days.
kind of ish, maybe.
First.
So today's 22nd, we'll still be reviewing. Your homework is still review packet, like the normal review packet we're going to originally have. Next class, we're going to just review again, and we might go ahead and do some transformations. I don't want to lose too much time, so we might do transformations. We'll see how things go. But your homework here then would be review number 2.
Cool. I like reviews.
So then the 26th, which would be Friday, will be your test. And most likely your homework will still be the translations and reflections worksheet. Translation and the smart board done. And okay, I'm sorry. And reflections. Worksheet.
Andrew, how does it feel that?
Your other test.
How does it feel to not be yelled at by Andrew today?
Long
Since
time
he's
before you
probably
got
on a
that.
cruise or something stupid like that.
Probably not. This-
So quizzes you don't get back yet. I have them halfway graded and I think it's taken. So you will get that. So it's like the same half for everyone. So you'll get that back to next class. Now let's talk about the formatting for the test, because this can be a little different than other tests that we've done because we have so many formulas. Now, looking at your quizzes, some of you believed me when I said you have to know your formulas. Some of you thought I was lying. I'm not sure why you thought I was lying. You must know your formulas. It's very frustrating when I tell you you must know your formulas and then you don't do a problem because you don't know your formula. You must know your formulas. And our test is going to be structured in such a way that you must know your formulas. So what I'm handing to you is actually the first part of our test. So let me pass this out first. You're not taking it right now. I'm just showing you what it is. Pop quiz. Yeah,
You said no.
Exact same question.
unless I find it.
Oh, it's right formula, lady. What's the formula good? What's the formula bad?
Cool.
What's bad?
Oh wait, so you would have to put no attempts.
Yeah.
Yeah.
I'll explain. First, I want to make sure that everyone get one.
We have to know this.
Okay. So,
No.
like I said before, you must memorize your formulas. And so what's going to happen is the very first thing you'll get for your test is this. It will look like this unless I find a mistake and I have to fix it. It is a blank paper where you have to write all the formulas because you must know your formulas.
Oh, cool.
Now, when you're done with this, you turn this in and you get the rest of the test with an SOL formula sheet.
Is that part of the grade?
So yes, this is a portion of your test grade. So the idea is that a portion of your test grade is based upon whether or not you know your formulas. But if you messed up your formula for cylinder on here, then you would have gotten every single cylinder problem wrong on the test. And I'd rather that I don't have to grade a lot of incorrect stuff. So then you'll get the SOL formula sheet, and the rest of the test will be, can you use those formulas? So just hold off on your questions. There are a couple things I want to talk about with the criticism. So again, what will happen is you'll get this. This is part 1 of your test. You will fill this out, turn it in, and then get your test with an SOL formula sheet. And you'll use that SOL formula sheet for the remainder of the test. Does that part make sense?
Yes.
Okay.
So,
Now, this here, I want to go ahead and make a couple notes on this. This is for you to keep, for you to look at, to study from. You must know your formulas. This is every formula we've learned in this unit. Our formula for arc length and our formula for area of a sector, we describe it as fraction of your circle times circumference, fraction of circle times area. The way that we actually write that out, the formula that we had written out is when they did fraction of the circle, they just used Q to represent the angle. So it's just Q over 360. And then if I'm talking about arc length, what am I multiplying by? Circumference or circumference? And what is our formula for circumference?
Pi d.
Good. Pi times diameter or 2 pi r. I don't care which one you do. Same thing.
are we writing this?
Yeah, you can go and write it down. That's the formula. Now, for formula for area of a sector, again, they just called Q the angle. So Q out of 360. So what fraction of my circle? And if I'm talking about area, what am I multiplying by? Area, which is pi r squared. Okay, so someone earlier was like, how do we represent the fraction of the circle? That's how I represent fraction. Angle divided by 360.
For like Q.
Okay, so what
Q
if
is
we
just
do-
your angle.
What if you do wrong formula, but it still works?
What?
So like if you do Q over 180 pi r, is that what you're talking about?
Yes.
Like if you simplify that, that would be fine. Or if you wrote it all together, Q pi r squared over 360, that would be fine. Yes.
For cylinders and prisms, what if you interchange like the P and the C for circumference for like for right there?
So you'll notice that prism and cylinder are written separately. So for your cylinder, you can just do circumference. For the prism, you'll look right here. Okay, so I want you to make a couple of stars on this paper. I want you to put a star next to formula for arc length, formula for area of the sector. And then a star next to kite/rhombus and regular polygon. These formulas are not on the SOL formula sheet, and so you do need to make sure you have those memorized for the duration of the test. Okay, so they are not on the SOL formula sheet, which means they're also not going to be on your SOL formula sheet for the SOL. You get to remember them for the SOL as well. Now, rectangle, base times height, you can write length times width, that's fun. But I don't think there's any other sneaky notations here. I went ahead and just wrote the reminder that we use a capital B to represent area of the base. So for example, my prism volume is area of the base times height, so you just make sure you use that capital B for it. Our pyramid, it's 1/3 of that. Just make sure you use that capital B. Okay. Questions with the expectation for our formulas?
So can we like take so this is ours to
This is yours to keep. Yep. Okay. So let me go ahead and show you the SOL formula sheet that you'll be getting. They actually changed it this year. It's a little different than years past, but it says 2016, but it says copyright 2018.
2016, no?
I don't know if it's because they're saying based on the standards for 2016, but they didn't put those in place until this year, so I don't know what they're doing. But this is the new formula sheet.
They're using the Mayan calendar.
They're using a time machine going back and forth.
It took really long to get the copyright.
Yeah, it took them 2 years to figure out what they were doing. Okay, so what I'm going to ask you now is this is the formula sheet that you get for the SOL. This is the formula sheet that you'll be getting for our test after you turn in your own points.
Can I write things on the formula?
You may run this because I will have my own like class copy that I'll give out during the test.
No, but on like the one you give out during the test, can I write on that one?
It's good. But I'm collecting it. The one that I give out during the test, can you write on this during the test? That's what you're asking.
Yeah, can I write on the one I get? So during the test, I'll get one, right?
You'll get an SOL, yes.
Can I write on?
No, that's a good question. It's going to be I'll have a class set that's ideally laminated to get it done by them. No, because no. Okay, so our formula sheet, sorry, I pulled it up on my screen, but not on yours. The couple of changes that they made this year is that they gave the formula for area of a regular hexagon.
What?
Yeah, so we have the formula for any regular polygon, which is what? 1/2 half. And they technically have that here. They just wrote it as PA rather than AP. But know that that's not only for a regular hexagon, that's for any regular polygon. It's true for regular hexagon. It's just true for any regular polygon. I just want you to know that it's true for any regular polygon, not just hexagon. So it's technically there, but you need to recognize it's for anything, not just a hexagon. So again, this is the first year they've used this, so my guess is that on the SOL they're going to do regular hexagon. They didn't used to have that, so
Probably just have it a lot.
yeah, that's my guess. So notice there are a couple of things that are a little different. We have just one general formula for our volume of any prism. And we talked about how a prism is not always a rectangular one. We could have a triangular prism. We could have a pentagonal prism. So the formula that we use for our volume is area of our base times height. And we use the same formula for lateral areas they have here, our perimeter times height. And we have the same formulas they have here for our surface area. Our lateral area is our lateral area, plus 2 of the bases. So this is what we generalized it as. They then went ahead and made a specifically rectangular prism one, you can use it if you want, but this is not the formula for any prism. Okay, this is only for rectangular prism. So don't write this on our formula sheet. When we go to write our formulas, if you write that for our prism, that's incorrect. This is for any prism. That one is specifically for rectangular. Okay, so just little things like that to be aware of. But yeah, otherwise, I think everything else is pretty much the same. Our volume here, we just write 1/3 area of our base times height. You don't have to write pi r squared on our test. You can just keep doing it the way that we've been doing it in class. But so this is for you to have so you know what you're getting during the test. Questions with this? Okay. So again, for the test, you will first get the blank formulas. You will fill that in. This is for points. You'll turn that in, and then you'll get the test with an SOL formula sheet, and you'll complete the rest of the test. Yes, Tom? It's a good question. I haven't decided yet. It will be a significant portion of the grade, but not like half. But it could be like 10. Great. Also, too, for your test, we are going to use calculators. So bring your graphing calculators.
Oh, does that mean we have to multiply by pi?
But listen, there are still instructions of leave it in simplest radical form, and there are still instructions of leave it in terms of pi. So that doesn't mean you get to just put everything in your calculator. You still need to know your 30, 60, 90 triangles.
No.
You still need to know your 45, 45, 90 triangles.
Well, the problem is going to be side cosine.
Yes. So now instead of having an answer of
Don't even
15 tangent of 70 degrees, you would actually have a decimal value for that. Okay. With that though, when we get our calculator, what's the first thing we do?
Degree mode.
Yes, clear, and then degree mode. Okay. So make sure you put in degree mode. You still need degree mode even for this unit. For geometry as a whole, we're just going to say degree mode. Okay. Are there questions with the structure or formatting of the test? There might be some. Yes, Jocelyn?
How are you so unprepared? I mean,
They haven't given us the proctor schedule yet, so I don't know. In general, it's not guaranteed. I think one year I was, but all the other years I was not.
like, our science teachers were like, out.
She already got it? How do I not know that? Maybe I know, but I didn't. I've been greatly participating.
Where did the pen go?
Is this the homework?
Yes.
No, I know.
Yes.
It's the 22nd of April.
We write as capital on the SOL sheet. I don't because it's not used for anything else. The capital B we use for area basic because we use a little b to represent like base distribution. Okay. So is there anyone that did not get the review packet? Okay. Take a look at the front side of your review packet. What's that? We're gonna go over this first one. Yes. Okay, I'll be here till 3:30 today. I need to check. I think I need tomorrow. I have to double check and see. Okay. So on the front page here, this is just our area of our regular polygons. And so that means you still remember how to find your apithone. And notice there's an octagon, a decagon. I could ask you for a dodecagon. I could ask you for a nonagon, a septagon, a 14gon. So let's refresh our memories of how we do it. Let's go take a look at the octagon. I think this one takes the most thinking for it. Okay. For this regular octagon, we don't have to draw the entire shape. It always comes back to
Triangle.
that triangle that's made with our apithone and our radius. Okay, so here's my apithone, here's my radius, and this piece is only part of my side. Okay, what did they give us?
The radius.
The radius is 20, so I'm gonna go and throw that in.
20.
Okay, so what's my area formula for a regular octagon?
Wait, here.
It's
One half,
one
no,
half.
one half.
Good, 1/2 ap. All right, do I know my apothum?
No.
Do I know my perimeter?
No.
Gee, what are we going to do?
Oh, there's 180 and minus 2.
Yeah, we do know our angle. We can find that. It's an octagon, so let's do our 180 times n minus 2. I don't have enough space right there. Where am I doing? All right, so my angle is 180 times n minus 2 divided by n. And our number of sides is what?
1,000.
What? 8. Good, thank you. You guys are good. You're just saying. Okay. So we get 180 times 6. 1080, I think is what it was.
Yeah.
Divided by 8. So what is one angle then? Time. There's 2 left over. 2 goes into 20, or 8 goes into 28 3 times. 4 left over. 8 goes into 45 times. Ooh, 135. Okay, so this entire angle is 135. Now, how much is this angle?
Half.
Half that. What's half?
Ooh, that's a difficult.
67.5.
67.5. That's exactly it. Very good. Okay, so now let's use that. How do I find my apothum? Sine, cosine, tangent.
She's having way too much fun.
Okay, which one do we want?
I want tangent. Because, you know, everyone has like
Tangent.
tan.
Oh.
No.
Everyone has a tan.
Oh, you got it. We got
Go with tan.
We got the hypotenuse. We got I paid
Go
some.
with tan.
Sine is opposite over
Oh,
hypotenuse.
I was looking at Jason.
Opposite and hypotenuse. Let's go with that. Alright, so sine of 67.5 equals, what's my opposite? A. My hypotenuse? That's the opposite of Jason.
So it's 20 times.
You said opposite.
Okay. Alright, so then A is 1 times sine of 67.5.
Calculator.
Yeah, so you use calculator crunch it. Don't round that answer though until the very end. Okay, so I'm going to leave it written like this. Don't round that when you put it into your. Okay, now I need perimeter. In order to have perimeter, I need my side. So let's find this little piece first. I'm going to call it X. So what do I use to find X?
Pythagorean? No.
So you use the Pythagorean theorem once you find what
You could do the Pythagorean theorem, but we could have to use that full decimal. What's
Oh.
an easier way?
Did you do cosine?
Cosine would be easier. So cosine of 67.5 equals x over 20. So then x is just 20 cosine of 67.5. Okay, so our formula is 1/2. My apothum, which was 20 sine 67.5. I'm just going to write it all out. Again, if you do this in your calculator, just make sure you use that full decimal. Now, what's my perimeter? Did we find perimeter yet?
No, you didn't find.
No, we only found our x there.
And you have to multiply that by 2 and then multiply that
Good,
by
so x is only this piece. My side then would be double that. So double would be 40.
Or could you just multiply it by 16?
Or you could just multiply by 16. Good. So here I'm finding my side, but then my perimeter would be 8 times that, which would be 120. Or as Patrick said, we could just go ahead and say, oh, if this is half the side, it's an octagon, I'd have 16 half sides. You could just take x and multiply by 16, or you can double it and then multiply by 8, whichever you prefer.
How'd you get this all?
I took my x value and doubled it. So 20 doubled. And then this is what we would be punched into our calculator. Okay, so again, if you find these values before, make sure you just copy and paste the full decimal. Do not round into the very, very
Can
end.
you just like do 20 over 2 to get rid of the half?
Then you would just have 10 times 320, so you'd have 3,200 sine 67.5 cosine 67.5. Yep. And that's what we would have had as our answer if we didn't have a calculator. Alright, so on your own, I'll let you guys actually punch into your calculator. But so again, just don't forget with our apothum, radius makes that nice little triangle. Sometimes we have 30, 60, 90 triangles. Sometimes we have pieces of triangles. Okay, any questions with that? The other remainder of class, just go and keep working on your review packet. If you want to keep working on the front page, welcome to, jump around however you so desire. Go and use your time to work on this. Yes, you may listen to music. So, I have the why. I know my name, but I don't know myself. So I have on yeah.
That's so good.
Sorry, it's good.
Sorry, I need to write.
Excuse me, that was not very nice of you. That poor eraser. Pardon my not good French, but okay.
I'm so not ready for
So,
If there's just like, if somebody I never did the beginning. I almost did the sub the first week ever, but then it turns out I didn't finish it. I was trying to get 100%. And he was like, no, I don't know. I'm just like down. I did that. Like, okay. Yes. I said, I only failed the first time. That's the only thing I haven't failed any of the tests, but I didn't have sex where I wanted to do three, just so I could get the highest degree in math. So I'm like, yeah, exactly. Like things like that.
no, so it looks like
But this one I do think I will do. No problem. Just Molly's and there's yeah. So people one Monza and it's they said it's easy know all the burgers. I know where the Boko is. And that was the nice Nile, falls down there.
I actually think that's the other way around.
Okay,
I know
Melody.
where the nice
No, because it's just changing to
I know where I don't know any of the that was so great. 800 packets, so 6. The one we got for the Gia. For the American flag.
Almost all that is gone.
Yes, that's that's not my Senegal, Congo, Limpopo, London. Oh, sorry, yeah.
So this one would be like tangent and thing and friends, or is Pythagoras?
Tangent and friends, I love that. I would probably just go and do the Pythagorean theorem because you don't know what your angle is. You could technically do inverse cosine behind your angle and then use that. But I would just do
No,
Pythagorean theorem.
is it not? It's a regular hexagon.
Right. So we want to do the 1/2, right?
Yeah.
So if you do Pythagorean theorem, that gives you your apothegm.
Mhm.
And then you can, once you have that, then you can go ahead and do your perimeter would be, what's 6 and then times all of the rest of that. Yeah, so I would do Pythagorean theorem because you have two sides. Our tangent in friends is when we only have one side of an angle. For any regular cosines, then we do 6 over 8. So regular polygon is like 6 sides. Yeah, it's fine. So like pentagon has 1 half. Yeah, but you said it. So.
3 square root of 3. Equals 3 square root of 3. That's crazy. Step 6.
Well.
So.
What? Decade. What's a decade? Dodeca, too.
I can see that.
What?
I just made the comment how I've always seen a word that.
Three.
She is better than
Guys,
this
number
one.
3 should say a regular hexagon.
Thank you.
The fact that it said Africa into was supposed to be that, but it should have said.
I knew that.
Oh, yeah.
What's half of a number?
This part.
You literally no, it's still.
What's that? 36? Is it 18, right? Half of 36?
What's it called where you have your
Half of 36 is 18.
Steve.
Yes.
I got to the.
Stop discouraging my learning.
I got to like the approximate equals
Sorry, it's just I don't really care. Exactly how I feel.
I'm doing number 2.
Because if it would be a number.
They make you do essays, don't they?
Yeah.
So for surface area, if we have like a pie, we just really apply it out.
Leave it in terms of fact. Leave it in terms of fact. But then surface area said do it times that. We had something said that. I forgot.
4.
Well, I haven't walked through it. I should have.